I'll be going to day 2 in the hole. So
Okay.
we'll come back to day 3.
That's fine. All right, let's go ahead and get started. We're going to run through a few examples together. Okay, and then juniors, you'll have the rest of class to finish. Seniors, you only need to do the ones we're doing together.
The first day that was clear, and then it wasn't, and then I ended up doing all of the
Good. Well, then you'll be extra ready for the TSI if you did 90 classes.
Already passed it.
Then your brain will just be smart.
Yeah, I mean.
All right. Okay, let's start with the second one on this page. So it says the mass of a certain bacteria grows exponentially, doubling every 20 minutes. What was the mass in milligrams of the bacteria 2 hours after it reached 10 milligrams? Okay, so first thing, based on when we're starting it, how much of the mass is there going to be? 10 milligrams. So do you remember this? Did we call it CE to the RT? Did we do this? Or we call it PE to the RT? Okay, it doesn't really matter what you call it. P though is where you put the principal. So sometimes you call it a C, but it's the same either way. So P is the starting amount. Oh, and then actually, I'm the worst.
No, you're not.
That is not the right one that we should use. It should be PR.
Oh.
Okay, sorry. So we're starting with 10. And then my rate is that it's gonna double. And then I want to count how many times it's gonna double. Now think about it, doubles every 20 minutes. And I want to let 2 hours go by. How many times will it double in 1 hour if it doubles every 20 minutes? 3. Because how many 20 minutes are there in 1 hour? 3, because it's 20, 20, 20 would be 60. Okay, so now I want to let another go by. How many more times is it going to double? Okay, good. Now, we're only going to count. So technically 3 and 3 is 6, but we're only going to let it double 5 times. Here's why. Remember that at the beginning, you only have 10. And then wait, it should be 6. Sorry, wait. I should have looked at this before right now. It should be 5. Because for the first 20 minutes, it doesn't double. And then double it. And then double it. So you do 6. Okay, put it in your calculator.
Teachers and students, please pardon this interruption. First, I apologize for the earlier announcement as it was over our eagle eye. And that was a big clown move on my part, and I am sorry.
Yeah, what?
Don't ever want any of y'all to miss eagle eye. So. Anyway, seniors, this is just another reminder that if you have B lunch, when the bell rings here in a few minutes, if you have B lunch, please proceed to the small gym to get your capping down. And
So
do that as well for C lunch. Thank you very much.
Okay, so you would do 10 is your starting amount, you're multiplying by 2, and you're doing it 6 times because 20 minutes is going to go by 6 times in a 2-hour time span. Okay? All right, let's see if we can do another one. Okay, let's do this next one. Okay, now this day is just kind of a collection of like kind of weird questions. They don't really go together as well as the other ones. I'm going to give you some like ideas of how I would solve it, but it's not like write an equation every time. Okay, so it says, you and a friend each have a can full of water. you start pouring your can at a constant rate of 4 ounces per second. While you're still pouring water, 3 seconds after you started, your friend starts pouring water from the same bucket at a constant rate of 2. How many seconds after you first started pouring the water into the bucket will it contain 24 ounces of water? Okay, so you might be able to do this with an equation, but to me that seems really confusing. So let's count 1 second, 2 second, 3, 4, 5, 6, 7, 8. Okay, these are going to be our seconds. Okay, then it says that I'm pouring how fast?
4 ounces per second.
Okay, so I'm going to have done 4, then 8, then 12, then 16, then 20, then 24. Now, I'm not going to keep going because I know that if I only want 24 ounces of water in the bucket, I would be done at 6 seconds. Okay, but remember, it's not just me pouring. My friend is also pouring. When do they start pouring? 3 seconds after you started. So 1, 2, not till 3 do they start pouring. And how fast are they pouring? 3 seconds after. Well, you're not really counting. You could put 0, nobody's poured anything. And then it'd be 1, 2, 3.
I mean, they started pouring.
And then they start pouring.
Going 4, right?
Okay, sure. Let's see if we get the answer that way. So it'd be 2, then they would have done 4, then they would have done 6, then they would have done 8, and then we're gonna stop there because remember, we need the amount poured all together to equal 24. So when do my amounts poured add to 24? At 5 seconds. So it would be letter G. Okay. So kind of weird math, but there might be another way to do it, but to me, that kind of makes the most sense. All right, go ahead and turn the page. All right, let's do directly proportional on this question. So it says X and Y are directly proportional and Y is 2 when X is 3. What is the value of Y when X is 9? Okay, so directly proportional means that you should use the same multiplier on both X and Y. So let me tell you what I mean by that. If I'm gonna like double X, I have to double Y because they have to increase by the same ratio. If I cut X in half, I have to cut Y in half because they're gonna grow and shrink at the same rate. Hang on, I have to tell Amari to be quiet. Okay, so look, write down your original X and your Y. So my X is a 3 and my Y is a 2. Then I have to think about what did I do to change my X to a 9? I times by 3. Then if I'm gonna times my X by 3 and they're gonna grow proportionally, then I need to times my Y by 3 as well. What would that make my Y value? 6. Very good. Okay. All right, let's do the next one. Down here, it says a square and a rectangle have the same area. The length of the rectangle is 196. The width of the rectangle is 4. What is the length of the side of the square? So first, let's just talk about the rectangle. How do I find area? Length times width. And they tell me that the length is 196. And they tell me that the width is 4. So can you, with your calculator, multiply length times width to give me that area?
784.
Very good. Write that number down. Now, that means that my square has to have the exact same area. What do I know about the length and the width, though, on a square? They have to be the same. not divide, what would you do? Square root, yeah? So on a square, your area is length times width, but they're the same. Then that would be like L times L, which would be L squared. Okay, now another option would be check these answers, times them by themselves, and see what gets you close to that 784. So if we do 20 times 20, that would be an area of 400. 28 times 28, that gives me 784. Okay. But remember, your length and your width would be you multiplying that number times itself, or you could call it L squared and then think like, oh, let me take the square root. Questions on that? All right, go ahead and turn the page. I think those are probably fine. Let's do the family budget. Turn the page one more time. Okay, it says a family's budgeted items are a fraction of their income shown in the chart below. Then it says what part of their weekly income is left for unbudgeted items. So think about, we need to add all of these up to know how much is budgeted. And then we're going to see how much is left over. So I want you to write down on your paper 3/8 plus 1/4 plus 1/8 plus 1/12 plus 1/16 plus 1/24. Okay. So the first thing I'm going to do is I'm going to try to find a common denominator for as many of these numbers as I can. So let's pretend the 24 is not here right now. Okay, out of the remaining numbers, the 4, the 8, the 12, and the 16, we can all turn into 16s. What would I times 3 by to make it a 16? Sorry, what would I times 8 by to make it a 16? So I'm going to times this one by 2/2. That's going to give me 6/16. What about the 1/4? What would I times it by?
4.
4/4. And that would be 4 times 1 is 4/16. Okay, for my 8, I want to make it a 16. So I do 2 times top and bottom. That would be 2/16. Now, I'm going to ignore the 12 because can I easily make it a 16? No. Okay, but 16 I can. That's a 1/16. So let's just start with the ones that can easily go together, and then I'm going to circle the 2 that we left out for right now. So now add your tops together. They're all over 16. 6 plus 4 is 10 plus 2 more plus 1 more. So all of these together account for 13 out of 16. We still need to add the 12, and we need to add the 1/24. Okay, our next step is going to be to find what is called the least common multiple that all of these can times into. Now, I can turn 12 into a 24, but I can't turn 16 into a 24. So I'm going to have to go bigger. 24 doubled goes to what? 48. Can 12 go into 48? Can 16 go into 48? Yes. So you have to find a common denominator that all 3 of your bottoms can match at. So let's times this one by 3/3. That'll give me 39/48. My 12, I can times by, if I want 48, that'd be 4/4. 4 times 1 is 4/48. And then this one, I can just double both. So 2 times 1 is 2/48. Okay, then add up the tops. 31 plus 4 more. That'd be 43. Plus 2 more would be 45/48. Okay, now think about, that means that 45 out of 48 is budgeted. How will I find how much is not budgeted? I'll need to count how many are missing to make this one full budget. It'd be 3 out of 48. So then I'm gonna put my missing amount would be how many more I would need would be 3 out of 48. Now, that's not an answer choice because it can reduce. What can 3 and 48 both divide by?
3.
So that would go to a 1. 48 divided by 3 is 16. So it would be J. Now, you might be wondering, I have a graphing calculator that can literally add that up for me. This is a TSI question, and you don't get the graphing calculator for TSI. So if you're taking the ACT, I would literally just whoop, punch that in, use the little pretty fraction, and you could go straight away to this step and then just minus what's left. Okay. Go down to your last one down here. Okay, you're asked to find how much monthly rent is. So let's read it. Says monthly rent charged at a store is $2 per square foot. The floor plan is shown below. How much would the rent be charged at this store? So what you're going to have to do is find the area. And then you're going to have to multiply by the cost. So let's say that this comes out to 100 square feet. Then if I have to pay $2 for every square foot, I would pay $200. So you're going to calculate the area, multiply by the cost, which it says is 2. Now, when I'm finding area, what shape is this?
Rectangle.
Rectangle. How do I find the area of a rectangle? Length times width. In your calculator, what's 30 times 60? Should be 1,800. Okay, next let's go to our triangle. How do I find the area of a triangle?
Or 1/2.
1/2 base times height, or you could do base times height and then divide by 2. That's also fine. Okay, which of these numbers are the base and the height? Not 39 because it's slanted. Very good. So in your calculator, do 1/2 times 36 times 18. Okay, and I got 324.
It's not a good practice.
For the top one.
Yeah, look, it doesn't-
A little bit, it's the glare.
There's no-
Where's their glare? Oh, on the calculator. Oh, they're so tricky. Okay, you're right. Is it a triangle?
Oh.
No, it's missing the tip. Then we can't actually use this. Thanks. Okay, you're right. It is a trapezoid. Last. Okay, so put area equals 1/2 base plus base times height. Okay, so let's think about, we need to know this little piece. If you don't remember from geometry, okay, the bases have to run parallel to each other. So when I'm talking about the base of this is one base, this is the other base. They have to be parallel. And so I didn't notice that because that cuts off early, it doesn't come to a point. That is a trapezoid. So we know this base is 18. This base is unknown. Let's think about how we could find it. Okay, if I know how long this is, how long is this?
30.
30. And I know that here to here is 33. Then how long is that little piece? 30. So now we can do our formula in our calculator. So type in the 1/2 first. So from here to here, it says is 30, right? So that means this is 30. That means that this is 30. So then from here to here is 33. Then that means this is the extra 3 to bump it up to a 33. All right, so in the calculator, we're going to do 1/2 parentheses. Base 1 is 3 plus base 2 is 18. And then the height would be the distance between the bases. So that would be this 36 right here. Okay, if you turn your paper sideways, let the base be the bottom, the other base be the top, then this would be the height. Okay, so we get how much for that?
378.
378, very good. Okay, and then now, since we've already reviewed the formula for a trapezoid, what shape is this? Also a trapezoid. And then remember, your bases have to run parallel to each other. That means that this is base 1 and this is base 2. So in your calculator, type in 1/2. Base 1 is 33 plus, and now I notice my base 2 isn't labeled. I can't use 27, but how long is this? 30, then how long is the whole base?
Wait, it wouldn't be 33, it would just be 30.
Correct. It would be 30 plus 27 would
No,
be.
for the first piece, it wouldn't be.
Ah, dang, you're right. Okay, thank you. This would be 30, because we're only using, remember, those top little pieces go to the blue trapezoid.
I just did the whole thing with the trapezoid.
Oh, you could do that too. That probably is easier. So this is 30. This is 30 plus 27, which would be 57. And then your height between them is 36. So it'd be like that. Okay, so we got 1566, and then we're going to add up those three numbers and then times by the cost. Now, if you didn't hear what Nate said, rather than breaking this up into two trapezoids, he just did one big trapezoid. That probably is easier.
Smart.
Yep, he's smart. He's the smartest. Okay, plus, and then this number right here, and then plus 1800. Okay, then from there, we're going to times by 2. So we get 7488, which is answer choice K. Okay. Now, let me also just say this is a hard test, okay? So just do your best, okay? No one's expecting perfection. Just do your best.
Your family.
Well, maybe your parents actually, they might be. I don't know. All right. Let's do this one right here. Okay, so it says the volume of a solid object is equal to the volume of water it displaced when completely submerged in water. So what that means is if I have a gallon, let's say of 10 let's say I have 10 gallons of water, it's totally full, and then I push an object into it, how much water comes out is the same amount of space that that object takes up, if that makes sense. So it says a solid is going to be placed into a rectangular tank that has a base of 35 by 30. And then it says it has a depth of 13. Okay, so there's your tank. And it says it's filled with water. How do I find the volume of that tank?
3 times all 3 numbers.
Times all 3 numbers. So it'd be 35 times 30 times 13. So go ahead and do that now, please. 35 times 30 times 13.
13,650.
Now, that is the water without the object in it. Okay, then it says, when the object is submerged, the new depth is 15. So rather than my water only coming up to 13, it's going to now come up to 15 in the tank. So think about if I change my volume to 15, that would be 35 times 30 times 15. Okay, so this is the water only. And then this is the new with the object. Okay, so go ahead and calculate that number. 35 times 30 times 15. And then what are we going to do with those two numbers? Very good. Subtract. So I would do this minus that. and you would get 2,100. Okay, an easier way, in my opinion, to think about this concept is think about like if you weigh yourself and then you weigh yourself holding your suitcase to go on a trip. Then you can tell how much the suitcase weighs by subtracting. It's the same idea here. Okay. All right, let's see. Oh, we're almost done. Let's do probability. Go to the next page, please. Okay, it says there are 20 children in the cast of a class play. 8 of the children are boys, and out of the boys, 4 have speaking parts. Of the girls, 8 do not have a speaking part. So let's break down. We have 20 kids. We're going to split them into boys and girls. Okay, and again, this is a strategy of how I would think about it. There are other ways to do it. Okay, how many of the 20 kids are boys? Then how many left are girls? 12. Okay, now let's break down into speaking and not speaking. Okay, out of the boys, how many have speaking parts? 4. Then how many of the 8 don't? 4. Very good. Okay, now let's talk about girls. We know there are 12 girls, and it says out of the girls, 8 do not have speaking parts. So how many would be left to speak? 4. Very good. Okay, then it says, if a child from the cast of the play is chosen at random, what is the probability that the child has a speaking part? Now, it doesn't say boy or girl. It just says they have to talk. So how many kids in the play are going to be talking? 4 here are speaking. 4 here are speaking. That would be 8 out of how many kids total? 20. So remember, you're going to put what you want out of the total for probability. Okay. So 8 out of 20, the answer is not there, but we can reduce to find what it is. What can both of these divide by? 4. So 8 divided by 4 is going to go to a 2. 20 divided by 4 is going to go to a 5. Answer choice A. Okay, one more left down here. Hopefully we know what a dot plot is. Basically, it's a bar graph, but every dot counts as 1. So it says the dot plot above identifies the number of pets living with 20 families. That means there should be 20 dots total. And it says what fraction, that's the same as a probability, have more than 2 pets. So for more than 2 pets, how many dots meet that criteria? Just these 4. Now, the 2s don't count because it says you need to have more than 2 pets, not greater than or equal to. So I want 4 kids, 4 families out of 20 families total, and then reduce to find your leftover. So it would be 1/5. Very good. Okay. I think I do want to do this top one. And then the rest of the time you can finish on your own. Okay, so it says, which of the following quantities is not rational? Okay, if you don't remember what rational means that you can either have a repeating decimal or a decimal that ends. It doesn't have to be a whole number, but it can't be like pi or something like that. Okay, so if I wanted to find the perimeter, what would I do to my rectangle? I would do 75 plus 75 plus 75 plus 75. Will that come out to be rational? Yeah. Yes. Okay, now let's do area. If I calculate the area of this, okay, and it tells me it's a square, so these are both 75, then I do 75 times 75. Is that going to be rational?
Yeah.
Yes. Okay, the next one says the length of AB. Well, AB is this distance right here. What is it? 75, which is rational. It's not a repeating decimal. Okay, and then it says the measure of, or the length of AC. how would I find that distance? Pythagorean theorem, so it'd be 75 squared plus 75 squared equals c squared. And then in your calculator, 75 squared plus 75 squared. Now that came out to a nice even whole number, but what do I still have to do? Take the square root. Okay, and then you can see that your decimal does come out to be irrational. Now, for your K, let's just talk about it real quick. Okay, if this is a square, okay, then what that means is that all four of these angles are 90. And when you cut it in half, what would each of these be? 45. Okay, so that would also be rational. So this one is square root 1125. Okay, I think that's enough for you to do together. So seniors, you guys are done. You have about an hour left. Okay, so finish up day 3. Huh? Yes. Yes. Thank you.
We vote like. All right.